morning, everyone. If you didn't finish your idea, you want to do it now. We'll have a little bit of time today. And these are not ideas that you are committing to for this project necessarily. It's just getting an idea down. And you want to put your name and highlight your name so I can easily give you credit for contributing an idea. Angel, what's the problem? It won't let you click on what?
On the link, it's like it's not a link. It's just like a a type thing.
Oh, in the chat?
Yeah.
Okay. Just a sec. Thanks, Nico. Yeah, so just that should work. Sorry. If you are done and you got an idea, just, proofread your writing, add a little something if you want to. You can always contribute more than one idea. I can definitely give you extra credit for that. Help each other out. I'm gonna kind of help you along this process here in a minute. I'll give you guys one more minute to get in here in the class, but I will give you a little time today to work on this. Yep, so you were responsible for one idea. So you were to pick a category on the left here in your table. And then finish basically the row, right? There's 3 things. So you want to pick a category, or you guys, I told you you can edit the category you don't like any of these categories and you think of something else, you know, what is the problem? And in this case, we like to think of problems as design opportunities. Who does this problem affect? And then how could Teachable Machine or something like it possibly be part of the solution, okay? And then definitely make sure to write your name. Like Anika has her name highlighted, Nico has his name highlighted. Makes it easy for me to give you a grade for contributing. I'll highlight Angel's name here. You know, again, if you want to add more than one, that's awesome. Okay, we're gonna move on. So you can keep working on that. We got some late arrivals today. So as a reminder, this week is all about getting ideas, looking at existing ideas, writing down ideas like you started yesterday and you're doing now. Today, we're going to talk a little bit about the ethical issues of artificial intelligence. Not that it needs to weigh heavily on your project for this unit, but it might inspire some of you to maybe point your work in a certain direction, okay? And then tomorrow, what we're going to do is you're going to really start to figure out where your interests lie, okay? Who do you want to do a project for? Like, do you want to like do something that solves a problem for a certain person or a certain group of people? Kind of moving towards getting these ideas, okay? So as a reminder, we talked about the example of Baymax, and the reason I brought him up was because he is a big idea, like a big, creative, fantastical idea that has an AI component, basically, a machine learning component, which are his scanners, right, in his hands. And the reason I bring that up is because when you guys are on this document right now, this possibilities matrix of coming up with ideas, I want you to think big like that, okay? I want you to think of big ideas that you may not even know how to create by yourself. You know, it would probably take years of college and graduate school to figure this out. And in addition, it would take many people on a team with you. But the idea is what matters. The creativity is what matters. And what you guys will end up doing is creating a model that is a small component of this big idea, okay? Because in reality, you could create something on Teachable Machine that represents what Baymax does, okay? And you've got to embrace that willful sense of disbelief, embrace your creativity, and at some points, embrace, you know, fantasy or make-believe, okay? We're going to watch a little clip right now. So if you're working on the matrix, pause for a minute. This video is a couple years old, just a couple, but it's great. And I want to show it to you because it's important to think about the fact that the world presents many messy problems. The world is a mess, right? Even more now than ever. And if you think about it in terms of that way, that there's messiness and there's no one answer, then the possibilities really open up. Okay. So when you're thinking of these ideas, it doesn't have to be like the best idea in the world or the best solution in the world, because there is no best, right? There is no one answer. So you want to keep that in mind. And this video shows some examples of like people working on projects. So it may give you some ideas. Okay, so we're going to watch this real quick. It's just a clip of one video. If you're on the slide deck, you can always go watch the full videos.
We wanted to make this an open source project so that everyone outside of Google could use the same system we're using inside Google.
There are lots of people who have made very, very creative uses of it without knowing a single bit of machine learning. So if they have the ideas, they don't need to do the heavy lifting that we've already done.
I saw a cool example where somebody used to have a cat going around their house all the time. So they trained a model to identify whenever the cat was there, and they would turn the sprinklers on to scare the cat away.
This elderly couple in Japan who ran a cucumber farm, and one of the big tasks is to sort the cucumbers into like prickly ones, less prickly ones, straight ones, curved ones, and it's actually a complicated task. So the wife would spend many hours a day sorting cucumbers. So the son picked up a computer vision model and was able to build a system to categorize the cucumbers and sort them automatically. All the time wasted sorting cucumbers is just going to be used in much better ways.
387 million people with diabetes are at risk for diabetic retinopathy. It causes blindness. The way that you can find signs of diabetic retinopathy is by taking pictures of the back of the eye. But there's just simply not enough doctors, and it takes hours for an interpretation. So we trained an algorithm that can read the images right then and there. The algorithm can help the doctors get more people screened for the disease.
The more you see machine learning and the kinds of things it can do, the more you see opportunity for it to improve people's lives.
You can use machine learning to save power at significant scales, even track the spread of diseases and epidemics.
We could use a computer vision model for everyone who's visually impaired.
We could make speech recognizer for everyone on the planet and drastically improve the experience of millions and billions of people.
I don't see any area of science or even of human endeavor that learned systems can't help with.
If you'd asked me a few years ago if a computer would be able to do this anytime soon, I would have said, I don't really think so.
It's very, very empowering to imagine what's going to come.
We're thinking thoughts and doing things that, no man has ever done, and sort of setting forth and setting foot in really new intellectual territory here.
The promise of AI and machine learning is that we can actually produce solutions to previously unsolved problems that will really help people.
Okay, so in that video you saw, or they explained at least 3 different ideas. One is like more of a fun, like kind of humorous idea with like, if the camera detects a cat on the screen, it turns the sprinklers on to send the cat away. So you might want to think about that. Like if the camera on Teachable Machine or the microphone picks up a certain sound, something could happen because of that. Even if you don't know how to make that secondary mechanism happen, it still can be part of your idea. And then the second idea was the son who was, helping his parents do their job, and their job as, I think, farmers were sorting these different types of cucumbers, right? So it's basically a matter of scanning 3 different or multiple sizes of cucumbers, and then the mechanism would be to sort it. Okay, so you could do something like that. And then the third one was a disease scanning tool, which we've seen examples of already. So when you're thinking of these ideas and getting them down on this matrix, you might want to think of ways to solve problems just around your house. You could solve problems for your parents or people that someone in your community, and then even just like a broader problem like diseases or something like that. I saw some really great ideas so far. We're going to talk about them tomorrow, but we do want to get them down today. Okay, so I'm going to send you into your rooms. And what you want to do, there's not a specific protocol today. I'm just going to give you 10 to 15 minutes of work time to finish this matrix, okay? So if you're someone in your group who has really just, it's kind of easy for you and it's like kind of fluid, you can put down an idea without a lot of stress, you know, reach out to those people in your group who have not put anything down and just ask them if they need some help, okay? And I'm not judging you on these ideas. This is just to get ideas down on the sheet, okay? So I'm gonna open up the rooms. You're gonna have about 10 to 15 minutes and then I'll bring you back, okay? I'll be here if you need help or if you're totally stuck, just come back to me and I'll help get your brain going, okay? You should know what room you're in by now. I'll put, yes, if you need to ask a question, stay behind. Here's the design cohorts sheet if you need a reminder. But you're just going into your room and helping each other get this done, okay? One idea each. Feel free to edit the categories. Duplicate categories, erase. Yep, we're finishing that page. Yes, Anika, I'll put you in your room. You. I'm gonna push Nico into his room. I'm gonna push Miguel into his room. Gyro into his room. Okay, Angel, what's your question?
I just had a question because I wasn't able to upload my link to the portfolio.
Okay, let me open your portfolio just a sec.
The one where we the teachable machine that we had to do over the break, I wasn't able to upload the link.
Okay, just a sec.
I put it on the classroom though. I submitted it.
Okay. Michael, do you have a question or are you late or did you get bumped out of your room? Oh, okay. Let me see if I can get you in there. So Angel, you couldn't get the link, like you couldn't
Like I couldn't paste it on the
okay. Okay, so let me set up your site. I don't know if you saw this on the weekly guide, but I recommended you guys start copying my layout for this project. Did you happen to do the video of someone using it?
Or what do you mean? Because you posted like 2 YouTube videos on your landing page.
Yeah.
And then I used those to guide me through the machine.
So if you, that's fine. On the written like Google Doc that I first provided you guys, there's a link to my site where it shows you how to set this up. And then, but I'm setting it up for you right now. And then what you want to do is you want to provide a model. I'm sorry, not provide a model. Upload a video of someone using your Teachable Machine model, okay? And this could be you or someone else in your house or a friend over Zoom. So let me publish that. And then let me go to, okay. Is this your model? This is yours right here?
Yeah.
Okay. Just be aware, like you always want to change the,
Oh, the name of the class.
yeah. I think if you open it in Drive, you could do that later, but, so let me copy this link. That should work. Okay. So basically what you need to do now is fill out this section. And then you want to upload a video of someone using your model. And again, that can be you. You could film someone in your house using it, or you can record someone over Zoom using it, like an advisee or even your advisor or something like that. Depending on what your classes are that you made for the model, it might not be universal enough where anyone can use it, so you might have to do it. Let me show you an example. I think Tatiana did hers already. Let's see. Yeah, so she has her answers here, and then she has a video of someone using it, okay?
Yeah.
So that's what you want to do. Got it?
Yeah.
Okay.
Okay.
So if you're done, do you have a question?
Oh no, that was it. I just couldn't upload the link.
Yeah, that's fine. So you can work on that. I think you already put an idea down on the sheet, so you can just work on this while we wait for everyone else to get back.
On my portfolio?
Yeah.
Okay. You want to ask me your question? Okay, I put it in the chat. I'll put it again.
All right, we are back. I'm just going through and making sure that your names are highlighted. You're getting grades for this today, so it is important that you finish it today. It was your homework yesterday, so most of you were able to state that this was your homework. So it should have been clear. Cohort 1, I'm a little concerned. It looks like Brock has his idea down and that's it, okay? So we have a lot of people missing for group 1, all right? So I'll be following up with you. So again, I'm gonna enter grades probably at the end of the day, so around 3 o'clock for this. It's really imperative that you guys are tuned in and doing what you need to do. So thank you. We see some names down here. I'm going to look through them. They look great. I was reading them while you guys were working. And again, you can erase my notes in red. I just put them there as an example, okay? All right. We're going to move on to the second half of class. We watch this video, and now we're going to talk a little bit about bias in AI and machine learning systems, okay? And so it's important to be aware of this because biases can influence your life, especially if you interact with technology, as many of you do. And like I mentioned, you may be inspired learning about this to create a project that is more equitable or center on an idea that is based on inclusivity, okay? So I want to ask you guys a question. I'll put this in the chat. Do you think anything built with AI machine learning technology can be 100% neutral and non-biased? Why or why not? I'm going to put the link to the Jamboard here. And you can hop on there and you can put your response. And if you go to that link, there's a refresher definition of bias. Bias is prejudice in favor of or against one thing, person, or group compared with another. Okay, so it's basically being prejudiced toward or against someone or a group. So, knowing that, do you think that when anything is built with machine learning, an app, a program, whatever, can it be, is it possible for it to be 100% neutral and non-biased? Why or why not? So let's take 3 minutes and just put your thought down. You don't have to cite sources or anything. Just grab a little sticky. And, you know, I think that it can or cannot be neutral because, did I spell neutral wrong? Yep, it's N-E. Okay. So if you want, you can just copy that format. All right. So just take a minute, go with your first instinct. Don't think too hard about this. Just seeing if we can get some responses. If you are stuck, think about how machine learning tools are made, who makes them. Oh, whoa, that is a big one. Who took up the whole screen? Was that me? No. Let's see if I can. There you go. Some good responses here. Good meaning thoughtful, right? Diverse responses. Let's take 30 more seconds. And remember, I can see who contributes and who doesn't. So definitely worth it to throw up your opinion up on the board. Okay, so take a moment, and if you did contribute as a class member, go ahead and read over these responses. There's some good, thoughtful opinions here. Depends on the situation. If you give it a simple enough task, it could be non-biased and neutral. Yeah, okay. This one's interesting, talking about it could be because humans have learned from their environment. Yeah, if humans are involved with what the machine is doing, then it'll pick up on the stigma and bias. Yes. Interesting. Okay. So we're going to use this as a reference point today or tomorrow, actually. So go ahead and finish your thoughts. And again, we're talking about this today, not because this is all what the unit is about. It's just to kind of, it's to expose you to the fact that there can be bias in machine learning and artificial intelligence. And we're going to see an example of this in a minute. So yesterday we looked at, where's that baby picture? If I take it out, we looked at the model of the model that guy built for his baby, right? And I asked you if it could be made to work for more babies or all babies. And we talked about the fact that if there was a more diverse data set, yes, it could be, but as it stood, it was definitely biased towards, you know, a white baby that looked like his, Eurocentric features. And we also talked about the fact that, you know, if the output was different, if it actually did something other than just say the word, it could actually reach more people. Okay, people who can't hear, or someone with low or illiterate reading skills, or even someone who just hasn't learned how to read yet, right? Like a younger kid. And so I'm sure you guys have heard or been aware of the fact that, you know, specifically apps like TikTok are extremely biased, and they're biased for a particular reason. And that reason is, you know, to point you towards recommendations that they think you'll enjoy based on your viewing history, and that only benefits them, right? Then there's more controversial information about coming out, or did come out a while ago, about you know, beauty standards in TikTok and how certain facial features are promoted over others. So I'm sure you've been aware of that. Most of you have used or know what TikTok is. So that is just an example of definitely bias that is present in technology, and TikTok uses artificial intelligence and machine learning in the way it runs. Okay. So we're going to watch this little video. Just gives you a very basic understanding of how bias can show up in machine learning. It's a good little refresher video. So we're going to watch it. It's a couple minutes long.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Okay, so that's a good little explainer. Obviously, it was biased towards Google because they made it, but I like it because it kind of goes over a very simple explanation.
Let's play a game.
No, let's not. Okay, so these are just 2 vocabulary words. You don't have to know these. I just have them in the slide deck. So you can have a reference point if you need them down the line. So algorithmic bias is basically bias in terms of what we're talking about for this unit. And socio-technical is a term that refers to how social and technical aspects of an organization or society are related, okay? So socio-technical is a very broad term. Basically, all the apps you use are socio-technical because they combine aspects of society and technology together, okay? But you don't need to write these down. They're just there for you, okay? We're gonna watch one more video today, and this is very important because it is basically gonna help you do your exit ticket, okay? So this is a video about a student, a graduate student. I'm sure she's graduated by now, actually. I think it's only a couple years old. About a project she did and sort of this research that she did based on biases that she discovered while she was in school. So the 2 questions that you're going to have to answer are explain the problem with the facial recognition programs that Joy, her name is Joy, evaluated. Okay, so what is the problem? And then what should have been done to improve them? What could be done to improve these programs that she's talking about, okay? So those are the two questions, and you'll be able to see the questions again after the video. So I think it's like 5 minutes. And then we'll have 5 minutes to complete the exit ticket, okay?
Good grammar and
I need to switch my, there we go.
Hi, I'm Joy, and I research how computers detect, recognize, and classify people's faces. In my TED featured talk, I spoke about my experience with the coded gaze, my term for algorithmic bias. The system I was using worked well on my lighter-skinned friend's face, but when it came to detecting my face, it didn't do so well, until I put on a white mask. After my talk was posted, I tested my speaker image profile across different facial analysis demos. 2 of the demos didn't detect my face. The other 2, well, they misgendered me. The demos didn't even distinguish between gender identity and biological sex. They just provided 2 labels, male and female. Now I wanted to see if these results were just because of my unique facial features, or if this was something that was more of a pattern across other faces too. So I began a project that became my MIT thesis, Gender Shades, or the long title, Gender Shades, Intersectional Phenotypic and Demographic Evaluation of Face Datasets and Gender Classifiers, or just Gender Shades. I wanted to see how well different gender classification systems worked across different people's faces, and if the results changed based on somebody's gender or their skin type. I created a dataset of over 1,000 images of parliament members ranked among the top 10 in the world based on their representation of women in power. To get at a range of skin types, I chose 3 African countries and 3 European countries, so I could see how the system performed on lighter skin and darker skin. Then I chose 3 companies to evaluate: IBM, Microsoft, and Face++, which has access to one of the largest datasets of Chinese faces. So now with the dataset and the companies, I decided to run a test. The companies appear to have relatively high accuracy overall. Microsoft performed best, achieving 94% accuracy on the whole dataset. All companies performed better on males than females, and all companies also performed better on lighter subjects than on darker subjects. When we analyzed the results by 4 subgroups, we saw that all companies performed worst on darker females. IBM and Microsoft performed best on lighter males, and Face++ performed best on darker males compared to the others. IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. I was surprised to see multiple commercial products failing on over 1 in 3 women of color. In fact, as we tested women with darker and darker skin, the chances of being correctly gendered came close to a coin toss. While more research is needed to explore the specific reasons for the accuracy differences, one general issue is the lack of diversity in training images and benchmark datasets. Failure to separate accuracy results across traits like gender and skin type also makes it harder to identify differences. Companies should do better with commercially sold products, especially since the machine learning techniques that have made gender classification possible are applied to other domains of computer vision, like facial recognition, and other areas of artificial intelligence, like predictive analytics. Predictive systems can help determine who is hired, granted a loan, or what information a particular individual sees. These data-centric technologies are vulnerable to bias and abuse. As a result, we must demand more transparency and more accountability. We have entered the age of automation overconfident yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine neutrality. The coded gaze reflected in the Gender Shades project must be faced.
Okay, so again, the questions are, explain the problem, just the general, she gave us a lot of information in 5 minutes, right? She was basically explaining her thesis, which is a paper you have to write in graduate school, basically no matter what major you graduate with, okay? So she's explaining her whole thesis in 5 minutes. So what is the problem, right? What was she talking about? And then think back, what should have been done to improve these systems in the first place? Okay, what could have been done? So that is the exit ticket for today. It's a little toughy. Yesterday was super easy, right? And I thought it was cute how you guys told me what other homework you had besides this class. But I'll put the exit ticket up. Hold on. And the questions are there on the exit ticket too. So I'm looking really, in your own words, what was the problem? And then what could have been done to fix it, okay? And I remind you that I bring this issue up because number one, you are interacting with these programs all the time, and you will as you get older. Number two, it might influence your thinking about this project. I don't know. And three, you all could be the people who fix these issues, right? You could be part of the solution. So explain the problem and what should have been done in the first place to improve them. Don't worry about using technical language, just in your own words. What do you think? And by this, like many exit tickets, I'll be able to kind of determine your understanding. And hopefully you learned something new, big or small. So after you are done, definitely go back to this sheet. Make sure your name is on here, highlighted, because I'll be following up with those of you who did not add anything. And that may be because you just don't have an idea and you need help with it, okay? So if you do have one, or if you can get something down, make sure you do it, okay? And if you need help, reach out and we can brainstorm really quick. All right, if you are done today, you may leave and I will see you tomorrow.
Bye, Mr. Wright. Have a great day.
Bye. You don't have any additional homework, okay? Unless you want to work on your digital portfolio.
Ms. Rivera.
Bye. Have a great day.
Bye, Ms. Rivera.
Bye. Bye, Leilani. I'll vote for you.